Finding frauds and scammers in society is dirty work. It is often thought to be left to superheroes who exist no more than in mere comic books, when in reality it is the silent heroes like Frank Benford who have harnessed the powerful tool of mathematics for the power of good and ultimately proving why we need maths. It is often hard to detect in today's society with email and social media. We have no idea who's behind the screen, and it is much easier to remain anonymous. Take Emmanuel Nwundu for example, a Nigerian scammer who sold an entire airport to a Brazilian bank in Sao Paulo that didn't even exist. Scams trick people appealing to the basic needs and hitting their soft spots, tricking them into giving up money without fulfilling what they've actually paid for. Step into the picture. Frank Benford, an electrical engineer during the 1930s in America, who had taken notice to an abnormality about a book of logarithmic. Numbers with the leading digit 1 were occurring more than that of the rest. After years of collecting data for this abnormality, Benford had finally come to the conclusion that the numbers 1 to 9 did not occur equally. Much rather, they are distributed as so. Numbers with the leading digit 1 have a 30% chance of appearing, 2 an 18% chance of appearing, 3 12% chance of appearing, 4 a 10% chance of appearing, 5 an 8% chance of appearing, 6 a 7% chance of appearing, 7 a 6% chance of appearing, 8 a 5% chance of appearing, and 9 a 4% chance of appearing. The formula for determining the distribution of numbers is as so. PD, the leading digit, is equal to natural log 1 plus 1 over d over natural log 10. The formula can be done in a calculator and works out the chance of the leading digit occurring, prices, river lengths, newspaper data, scientific data, and more. The law, however, does not apply to made-up numbers and thus can be used to discover frauds. The law also doesn't apply when the range of numbers is not from 1 to 9. Take the height of players in the English Premier League. Their heights range from the smallest player, Pedro, who is 5'6", to Costel Pantamillion, who is 6'8". The range of the leading digits is only from 5 to 6, and thus only these numbers would appear, skewing the data. In America, someone was accused of fraudulence when there had been too many check payments beginning with 8 or 9. These numbers have the least amount of chance of occurring according to the probability of appearance determined by Benford's law. The accusation and then prosecution proves why we need maths. While being law and order, it maintains law and order. Another example of Benford's law in everyday society is when a lecturer, Mark Ningrini, had asked his students to look at the accounts of businesses that they know. One of his students decided to look at their brother-in-law's hardware store's numbers. Began with 1. The remaining 7% either started with 8 or 9. The numbers had been so skewed that there was no way that they were real. In fact, much to the student's surprise, they discovered that the brother-in-law had in fact fabricated these statistics. Benford's law has been used countless times to seize frauds in their steps and stop them in their tracks. Without Benford's law, criminals could be getting away with these crimes, ruining the economy, which could have even further and more drastic consequences. It can therefore be concluded that Benford's law is of the utmost importance. Frank Benford is an unsung hero. His law allows forensic accountants to find scammers and frauds through his law, determining the percentage of occurrence in a leading digit and thus proving why the world needs maths.